He's retired now, and we wanted to create this video so that future master gardeners could enjoy his vast slide collection and his knowledge of plant pathology.
Disease in plants, of course, is an injurious disturbance in the form and or the function resulting from a continuous irritation. Before we can have disease, we have to have some things present. First of all, we have to have a plant, of course, but not only a plant, we have to have a plant that is susceptible to any given problem. And so we have a special term for that. We call that a suscept. We also have to have an environment which is favorable for any given disease to develop. Many times we have an interaction between the plant and an environment, and the environment is not favorable for the growth of the plant, and so we have a disease result from an interaction between the plant and an unfavorable environment. Such diseases we call non-infectious diseases. They're non-infectious because there's nothing that can spread from one plant to another. And there are a lot of those, and of course you're all familiar with them. If we just mention one right off the start, nutritional diseases are non-infectious diseases. Then we have lots of diseases where there are causal organisms, and the causal organisms can vary from one type to another. We can have bacteria, we can have phytoplasmas, and we'll talk about those in a minute. We can have fungi, we can have viruses, we can have nematodes, we can even have some problems with insects because they fit our definition of disease, and we'll talk about that when we get there. No problem whatsoever. Such diseases, of course, are called infectious diseases because something can move from one plant to another, and in that way we can have a new disease developing in another area or in another part of the field or in another part of your garden, wherever. In a disease situation that we call infectious, we have three factors: the suscept, the environment, and the disease-producing agent. You can call it a disease-producing agent. We frequently speak of disease-producing agents, and these are living things, as being pathogens. We have an interaction between these three things, and the most critical thing to remember about this is that no single factor is more important than the other. In other words, you frequently hear it said that if there's a disease-producing agent in the area, you're going to have disease. You're not going to have disease unless you have that disease-producing agent there in the presence of a susceptible plant and in an environment which is favorable for disease to develop. And all of three of these are equally important. No one is more important than the other. When we talk about these diseases, each one of these diseases, first of all, we're going to take the non-infectious diseases and we're going to talk about those in each group. Then we will talk about those diseases which result from infection by bacteria, and then we'll go into the ones with fungi all the way through. So in each group of diseases that we're going to talk about, we will divide them up as to what is the causal agent or what is the cause. The way I've divided the diseases up today is based upon symptoms. Symptoms are defined as visible manifestations of disease as shown by the plant. In other words, if you go out and look at a plant and it has a big spot in the middle of it, that's the plant responding, and that is a symptom. We mainly diagnose plant diseases by symptoms, but we also sometimes are able to diagnose plant diseases by looking at the causal agent itself. Powdery mildews, for example, you would diagnose that disease by seeing the causal agent. That's known as a sign. And you will find that your outline is divided up into two sections: symptoms and signs. We will take different types of symptoms and discuss them in a group because that's the way you're going to look at them. You're going to see symptoms that are somewhat similar. And so we've divided this up into a group of different symptoms. And the first symptoms we're going to talk about are those where there's a killing of tissues. And of course, plant pathologists aren't happy with a little tiny, a big word like killing of tissues. They have to have something complex. So they call this necrosis. Necrosis is killing of tissues. And we're going to start with very small portions of the plant, and then we're gradually going to kill more portions of the plant, and gradually we're going to kill whole plants. And when we get through with the killing of plants, then we'll start with another symptom. And then we will go through each of these symptoms, and in each group we're going to take, first of all, the non-infectious diseases that are involved in that. Then we're going to take those that result from bacteria, phytoplasmas, fungi, viruses, nematodes, and so forth. So you're going to go through a lot of these different causal agents each time we have a different set of symptoms. But the reason we do it this way is because there are a lot of things that look alike, and yet they're completely different when you find out what the real cause is. And so this is why we're doing it on the basis of symptoms. Most plant pathologists classify plant diseases as to the type of causal agent. We're going to do that, but we're going to do it within a symptom expression group rather than as the whole cause, okay? With that, I think we should start looking at the slides. The first symptoms that we're going to look at, you remember, are necrosis. We're going to talk about necrosis. What does necrosis mean? Killing of tissues. Oh, you're good. We're going to start with necrosis in small areas. And so the first one we want to look at is a problem that we see very, very commonly, a killing of the tissues around the margins of the leaf. This occurs first on the older leaves on the plants, and this is due to salt damage. Excess salts accumulate in plants. They accumulate on the older leaves because they've been on the plant longer. They accumulate around the margins because the salts accumulate at the ends of the veins. Eventually they reach a concentration where they're high enough so that they kill the plant tissue. And if you see that, you can almost be certain that you have salt damage. Salt damage is very, very characteristic. Usually dark brown, not always, but usually. And if you see that, you know you have salt damage. Sometimes it doesn't go all the way around the leaf, but far enough so that you can be suspicious. So if you see a leaf that doesn't go all the way around, don't say, well, we have to eliminate salt damage. You see, you say, well, that looks pretty much like salt damage, and then you look at other leaves on the plant. In diagnosing your problems, you probably never want to look only at a single leaf. I realize that sometimes people are only going to bring you a single leaf, and we have this problem too. But if you can look at more than one, that will help. This is a philodendron, and the reason that I put it in is notice that there's a yellow area between the dead area and the green area. You notice the other slides that I showed you, there was no yellow area. So the yellow is a variable characteristic, and you want to be sure that you don't say, well, there's yellow there, it can't be salt damage. If there's yellow there, it can be salt damage. It's just that it varies from one plant to another. Here's a plant that perhaps you know if you're a house plant grower. This is Maranta, the prayer plant. Have you ever seen that without any salt damage? No, it's very, very sensitive. One of the most sensitive plants we have. And if you grow that plant, you probably will end up with salt damage because it's so sensitive. Here's another plant that has salt damage all the time. Spider plant. Did you ever grow a spider plant that didn't have dead tips? If you did, you're pretty good because it's very, very sensitive to salts. Now, where do the salts come from? Well, they could be in the soil to begin with, but probably not. They could be in the water that you're using to irrigate, and this is a possibility. And it could be from fertilizer, improper use of fertilizer. Also, it can be just from not leaching the plants correctly. Now, salt damage is much more common in plants that are grown in containers than it is in open ground. Don't say I said it doesn't occur in open ground. It can, but it's much more common in plants that are in containers, and it's because we do a nasty job of growing plants in containers. We do everything wrong, and no wonder those poor plants suffer. Some of them suffer even more than others because they're so sensitive that they will always have that problem unless you do everything just exactly right. One of the interesting things that we're learning and we didn't know about till just in the last several years ago, some water districts, because the water that's going through the pipes is acidic, and because acidic water eats on metal pipes, they put sodium hydroxide in the water in order to pull it up so it's above neutral. And East Bay Water District, I was told this just recently. I was in Half Moon Bay and I was told that the water district in Half Moon Bay, they put enough sodium hydroxide in the water so that the pH of the water is 8.1. Well, sodium, unfortunately, is very toxic to plants. Even more unfortunately, plants don't use sodium at all. They have no use for sodium whatsoever, and so it accumulates, and so you can get salt damage very easily. So you have to be careful about how you grow your plants, and the best way of taking care of it, of course, is to grow them with all the tender, loving neglect you can give them, okay? This salt damage I put in just because we know what it is. This happens to be boron. We tested the leaves, they were high in boron. We tested the soil, it was high in boron. But the reason I put it in is it looks just like any salt damage, but any salt in excess can cause this trouble. And that's what we have to worry about. I told you that it's usually only on the older leaves, but once in a while you may see it on all the leaves of a plant. This is a rare situation, but this poor little rhododendron has salt damage on every single leaf. Too much fertilizer. How do we correct it? Well, we correct it by leaching. As I said, we have more problems with this growing in plants in containers than we do in open ground. So if you're going to insist on growing plants in containers, you might as well do it correctly. And that is to be sure you always water the plants from the top. Put the pot in a saucer, put 3 little blocks of wood underneath the pot so that it raises it off the saucer so the water can drain out, and then occasionally put enough water in the pot so that the water drains through. Never let the plant sit in that water that drains through, because that's where the extra salts are, and if some of that water evaporates, that's going to increase the salt content in that water, and if the soil goes dry, that's going to go back up into the pot and it's going to aggravate the conditions. Now, I know none of you ever let your plants sit in the water that drains through, but I talked to a gardening group a couple weeks ago, and one little lady admitted that she did that. But she also came and told me that she wasn't going to do it anymore. So be sure that you get rid of that water. Now, the reason I have a turkey baster there is because I talk to lots of gardening groups with sweet little old ladies, and they tell me they cannot lift a heavy pot. So buy a turkey baster, don't pay more than 69 cents for one on sale, and put it right by your plants and use it for sucking up that water. You don't have to lift the pots out at all. Very simple, easy way of doing it. Now, I told you occasionally you put enough water on to run water through the pot. Or you're going to say, well, what do you mean by occasionally? Okay, let's talk about that. With most plants, which are not extremely salt sensitive, I would say once every 2 or 3 weeks is adequate. If you have a salt-sensitive plant, such as Maranta or any of the ferns, particularly birdnest fern, Splenium, or if you have spider plants, every time you water, you should run the water through. If you do that, you'll be surprised. You can even grow spider plants without any dead tips. But you have to do it every time. I have a friend who lives in Los Angeles. She lived next door to me when we were in high school. She couldn't understand why in the world anybody would be stupid enough to carry seed catalogs around in his notebook all the time. Eventually, she became very, very intelligent. In her old age, she became interested in plants, and she understood exactly why I carried seed catalogs around in my notebook all the time. And she has a small apartment, and the whole wall and the whole window area is filled with plants. And she does a beautiful job. I didn't tell her what a beautiful job. I didn't see any salt damage. But I asked her what she did to her plants. She said every week on Saturday, I put my plants in the bathtub, and I turn the shower nozzle on, and she said I give them a good soaking. And she does a beautiful job, and that's all it takes. Good leaching, and that's what she was doing. Okay, another disease where we have necrosis is sunburn. Sunburn appears as a killing of the tissues between the veins. Now, sometimes you will see that the veins, that the dead tissue is close enough in areas so that they will coalesce, so it will cross some veins. But usually, sunburn appears between the veins. Sunburn is very, very common, and I used to think that it was due principally to excess sunlight. After looking at plants for a little while, I've decided that the main cause of sunburn is lack of water in the plants. If a plant goes dry, it will sunburn. If a plant has adequate water, it will not sunburn. Now, there are exceptions, and we will talk about some of these exceptions. But in general, that's the main cause of sunburn. And very obviously, this rhododendron went dry, and it sunburned. One of the early symptoms in sunburn is a color change. There's a loss of the green color. We call that yellowing. Actually, the leaves don't turn yellow. The leaves are already yellow. It's just that when the green chlorophyll is there, it masks it. If the chlorophyll disappears, then the yellow appears. But we say leaves turn yellow. They don't turn yellow. They already are yellow. Here is ivy, the sunburn between the veins. The sunburned tissues will vary in color from one plant to another. So sometimes they will be bleached. You notice the rhododendron was brown. That doesn't make any difference. It just is that it's very characteristic if it's between the veins. We commonly see sunburn on ivy. Why? We're nasty to ivy. We plant it, we say we can get by without doing anything. We don't water it. We have a real hot sunny spell and it sunburns. And then we say, oh, we should have watered it. And we go and water it, so the new growth comes and it covers up all those sunburned leaves, and then pretty soon we forget about that and we let it go dry again, and then it's sunburned. And we just recycle this year in and year out all the time. We have a clinic in Berkeley. Man brought these in one day, called me up in advance. He says, I have a brand new disease on tomatoes. He said, this is something I've never seen before. He says, I don't think you've seen it before either. I said, okay, bring it in. He brought it in, and I said, you let your tomatoes go dry, didn't you? He said, how did you know? I said, well, the plants are telling me. I said, that's sunburn. And he said, well, you're right. He said, I did let them go dry. This was a little experiment that I ran just to see what would happen. Some plants have very narrow leaves, which means that they're constructed so that they don't lose much water. This happens to be a dianthus in the carnation family. And so I wondered what would happen if I let some of those plants go dry. So out on my driveway, I put 2 pink plants, pink being not the color but the name of the plant, dianthus, and in one of them I put water every day, and the other one I let go dry just to see what would happen. Well, interestingly enough, the one that I let go dry, the flower sunburned. The leaves did not. So sometimes you may see this in flowers too. One of the exceptions to plants going dry and sunburning is if there is a lack of chlorophyll in the leaves for any reason. It doesn't make any difference what the problem is. This happens to be a virus in rose. This happens to be from my own garden. By the way, a lot of these things I'm showing you are from my own garden. I have a fantastic disease collection, you see. I don't have to run around the neighborhood and look for disease. They're all right there. Well, this was in my garden. I predicted that we had a real scorching hot day, and this beautiful rose virus causes the chlorophyll to disappear, and so I figured that we'd have some problem. And the next day I went out, and sure enough, it was sunburned beautifully. Well, you're going to tell me 2 things. You're going to say, well, let's surround the margins, and it sort of looks like salt damage. And it does, but it doesn't go all the way around the margins. And also, this is up on the plant. You can see some leaves down below, and there's no burn on those. So this tells you that it's not salt damage. And then you're going to tell me, but you said sunburn occurs between the veins. And this isn't between the veins. But sunburn occurs between the veins when there's a lack of water in the plant. And water, the last place to have water in the plant is the veins, you see, so that's going to be the last place to sunburn. So that has nothing to do with this, because this has no chlorophyll to protect it, and it's not even connected with water, okay? Well, here's a beautiful, beautiful sunburn. The side of the leaf on the bottom was getting more sun than the upper portion. So it burned more, but the other portion is beginning to burn because, remember, I told you one of the early symptoms of sunburn is a color loss. And you see that color loss along there, and then you see some of the tissue beginning to die, but on this side, a lot of the tissue. Now, sometimes the tissue is discolored due to the fact that an organism, a fungus, will go in and will work on that dead tissue, and you can see that beginning to happen up here in some of these spots. Another problem that can cause color loss in plants is a nutritional deficiency. This happens to be iron deficiency. Both of these rhododendron leaves are showing iron deficiency, but the one on the right is showing a lot more, and you see it's beginning to sunburn as a result of not having enough chlorophyll in the leaves. Do you grow a cuba down here at all? Gold dust plant? Well, the one that has those great big yellow blotches, and by the way, that's a natural variegation. That is not due to disease or any other problem. It's just natural. That big yellow area frequently turns black. And the reason that it turns black is sunburn. And that plant is just saying that it's getting too much sunlight and needs to be planted in more shade so that you don't have such a problem with it. Fruits also can be sunburned, and again, it has nothing to do with water in the plant. May have something to do with good foliage cover. Tomatoes, if they do not have good foliage cover, the fruits that are exposed, the shoulders will sunburn. And that tissue will never ripen. It will stay that color. It will never get soft. It will be hard. There's nothing wrong with it. You can eat those tissues if you want. They're sort of crunchy, but they don't taste badly. And if you want, you can use those. If you cook those tissues, they still will stay crunchy. So you can use sunburned tissues. You just have to learn to get used to the crunch. That's all. If you have this happening in your tomatoes, check to see what's wrong. Maybe you have a disease problem that's preventing the foliage from forming the way it should. Maybe the foliage isn't growing out where it should cover the fruits the way it should. Lots of problems, but it has to do with the fact that the fruits are exposed too much. Same thing happens with peppers. Peppers sunburn very, very easily if they get too much sunlight. Those of you who are around walnut trees know that walnuts frequently will be sunburned on one side. You get this nice elliptical brown area on the upper portion of the fruits that's exposed, and that's just sunburn, and it means that, again, there's not enough foliage on those trees to cover the fruits. Apples even will sunburn. I even had it happen in my own garden this year. That was unusual, and I don't know why, what caused it, but I'm not going to worry about it too much. Another disease where we have necrosis is if the plant picks up something from the soil, which is very toxic. If it does that, it kills the tissues right down the veins, and you can see this. The tissues right down the veins are killed. The chances of finding out what killed that tissue are very small. Frequently, when people bring me something like that, and the woman that brought this to me said that she hadn't done anything different to her little Japanese maple. And so I said, well, do you get along with your neighbors? And you'd be surprised. Neighbors sometimes do something if a tree is in the way and they don't like it. She said, no, we get along fine with our neighbors, but she said, we live near the university and anything's apt to happen there. Well, I would agree with that, too. I suggested that because this was a deciduous tree, that she irrigate it as much as possible without causing too much problem, and then wait till the following year and see if it leafed out again all right, and then to come and tell me. And she said she would do all those things, but she never came and told me, so I don't know if this tree made it or not. Here's a fiddle leaf fig, came in from one of the libraries on the campus. A young lady who was in charge of the plants there was very, very upset. This was a great big plant, and practically all the leaves on the plant had those dead areas. And I said, what in the world did you do to that plant? And she said, nothing differently. And I said, are you sure? And she said, yes. And I said, well, we better explore this. I said, did you have a party in your library? And she said, oh, yes. And I said, was the party about a week before this symptom appeared? And she said, oh, yes. And I said, did you serve alcoholic beverages at your party? And she said, yes. And I said, have you figured out what happened to your plant? And she said, yes. Somebody didn't like their drink and they poured it in the pot. And alcohol is extremely water soluble. It was picked up and carried right out to the ends of the veins and killed virtually all the veins on that plant. If you look at the underside, it killed the tissues even further than it did on the upper side. Nothing you can do. She wanted me to write her a formula to get that plant to recover. Those tissues are dead. You can't bring them back. The question is, would it grow new leaves? It would if you cut the plant off. Or if you cut all the leaves off and left just a couple at the top to manufacture food. It probably would sprout new leaves, but it might take a long time. Another place where we have necrosis is if a plant goes dry and part of the tissues go beyond the wilting point. If tissues go beyond the wilting point, they die. They will not come back, even though the plant may get water again. But when they die for this reason, they have a very, very characteristic symptom. And that is the tissues die, but they retain a dull green color. Those tissues are dead, they're brittle, you can crumble them in your fingers. And if you see this, you know that that plant went dry. Very characteristic, very diagnostic. Here it is in a hydrangea plant. I gave this plant to a friend. One day I went by and it was sitting on the front porch. And I said, you let your hydrangea go dry? She said, oh, no. And I said, oh, yes. And she said, well, oh, maybe a little bit. I said, oh, no, a big bit. She said, I don't think so. I said, I know, I don't think so either. I know so, you see. Nothing looks like that. You see, that plant went dry. And it even, look at how the area around the veins tends to be green farther than the area between the veins. It's just telling you that water was involved. I could tell you about lots of arguments about people. They don't want to believe this. And this is one of the things that you're going to have to recognize when you do your Master Gardener program. People are never going to tell you what they did. And if you suspect something wrong that's very simple, they're not going to believe that either. You're going to have to become a diplomat and explain all these things very, very gradually, because they don't want to believe that they could in any way be responsible for what's going on. It has to be a magic new disease that's coming in, and they want you to wave a magic wand and get rid of it, you see. Well, here's a beet plant. In my garden, I let that plant go dry, and it did what it's supposed to do. It turned brown around the margins, retained that dull green color. Now, sometimes they may turn tannish or brownish, but if you see that dull green color scattered through there, that means that it went dry. Sometimes, when you see this in your lawn, you are suspicious of many, many things. I used to take my daughter's dog for a walk. No, that's not dog damage. I used to take my daughter's dog for a walk, and this was past the school. And one day, the man that was in charge of all this said, "What's wrong with my lawn?" And I said, well, are you watering it? He said, oh, yeah, 3 times a week. And I said, how long? He said, oh, maybe a couple hours. Well, I said, you're doing it pretty correctly. I said, have you ever checked it while the sprinkler's on? Oh, yeah. I said, are you sure? Well, I think so. I said, go turn the sprinkler on. And he did. The sprinkler hit everything except for that brown spot. But you see those little tiny green patches out there? Every once in a while, some water would squirt out there and hit those. I said, why don't you fix your sprinkler heads? He did. Within 3 weeks, that lawn was all green again. It's just lack of water. Another time we have lack of water is with fairy ring. You all familiar with fairy ring in turf? Fairy ring results, it's a nice big circular area where the grass turns sometimes tannish or brownish, and the fairy ring eventually expands, and then the grass goes back green again, so you just end up with this ring wherever the fungus is active. There are papers that say that this fungus is producing a material that kills the grass, but it doesn't kill the grass, because as soon as the fungus in the soil has used up all the nutrients, and it's just a fungus that's living on the organic matter, and as soon as it's used up all that, then it moves on into the area where it hasn't been before, and then the grass, as soon as it moves on, the grass can become wet again, the grass can begin growing again, and the reason for it is because when the fungus is there in the soil, it dries the soil out so much that the grass can't get any water. You see, we dug out a plug in front of that ring of fungus, and see how nice and dark the soil is with moisture. We dug it out right in the ring where the fungus was working, and you can see that that soil is just bone dry. And the reason for it is because that fungus is impervious to water, and when the water comes on, it hits it and it runs off to the side, and so nothing can happen. Even more interesting is the fact that you can see the grass beginning to grow right behind that ring as the fungus is no longer active, but notice that that ring is darker green. And the reason it's darker green is because the fungus has broken down some of the organic material and has released some nutrients to the soil, and so we have extra growth coming right behind that growth. All this whole thing is due to is lack of water. We can have the same thing if you allow too much thatch to build up in your turf. You see the plug at the top has a lot of thatch, and notice that the soil underneath it is bone dry. Taken right next to it where the grass was doing very well, notice that there was not very much thatch, and notice that the soil is moist. It's just a matter of moisture, that's all. Uneven water. Uneven water can cause problems, particularly in tomatoes. Have you all seen blossom end rot in your tomatoes? Nobody seen blossom end rot? Okay. It's very, very common. Blossom end rot results from uneven watering during the time when the plant is beginning to produce tomatoes in the early part of the growing season. If you give the plants an even water, don't let them go dry, just keep them nice and moist, you won't have this problem. Now, we've been saying this for years, but plant physiologists aren't happy with that answer. And they've studied it, and they've found out that actually the thing that's a basic cause of blossom end rot is lack of calcium in the fruit. It's not getting enough calcium. Well, our soils are not deficient in calcium, so that shouldn't make any difference, except if we don't have enough water in the plant to carry the calcium into the fruit, then we're going to have blossom end rot. So it's an interaction between lack of water at certain parts of the growing stage of the plant and calcium not getting into the fruit. If you keep that water supply going, you won't have blossom end rot. No problem at all. We had a graduate student working on a problem on tomatoes. He had plants that were almost the top of the greenhouse, great big huge plants, loaded with tomatoes, and every single fruit on those plants had blossom end rot. And the reason for it is that in our greenhouses, plants get watered twice a day, whether they need it or not. Doesn't make any difference. And they just weren't getting enough water between those two irrigations, and so when I needed blossom end rot, all I had to do was go down to that green, and there was an abundance. And there are some of the ones right from his plant. It started very early because there was so much water stress on the plants. Now, one other interesting thing about this, and that is that as we go towards the end of the growing season, you won't see this. Hardly any blossom rot at all, blossom end rot occurring. And even if you let the plants go dry, well, probably the reason for it is that the plants aren't demanding as much calcium in their growth, because calcium is necessary for the new growth. And you see, if the plants aren't growing much anymore, there's probably still enough calcium available, and so there's no problem. So you won't see this late in the growing season.